Well, hello everyone. Welcome to our webinar entitled ComSat-3 and ComSat-5 for monitoring applications. Today we will look at ComSat-3 and ComSat-5 imagery and how it can provide very valuable information to detect changes and how it can be used to implement operational monitoring programs. Also, today we will demonstrate how to process SAR and Optical ComSat images to automatically detect changes using operational workflows in Geomatica. Geomatica is a powerful geospatial image processing software suite used by professionals, researchers, and students around the world for fast and accurate image analysis and production. Geomatica provides visualization tools, support for the latest satellite and aerial sensors, and over 550 algorithms to manipulate and extract information from imagery and related geospatial data. Geomatica provides a powerful workflows for orthomosaicing through OrthoEngine and automation capabilities with our Python API. In this 60-minute webinar, you will learn mission characteristics and details on ComSat-3 and ComSat-5. You'll learn how to ingest and process ComSat-3 and 5 imagery in Geomatica, basic image processing workflow elements such as atmosphere correction, pan sharpening, mosaicing, and how to perform basic monitoring workflow tasks such as classification, change detection, and extraction. So just a reminder that all the lines will be muted during the presentation. If during the course of the presentation you have a question, please type any question or comment you have into the questions panel, and we'll be having a dedicated Q&A session at the end of the presentations. Also, please let us know if you have any trouble hearing the audio or seeing this screen by sending us a chat message or raising your hand. So for this webinar, we have myself, Jean-Sébastien Bouffard. I'm a technical solution specialist at PCI Geomatics, and I will be your host here today, and I'll be presenting a portion on monitoring applications in Geomatica. I've been at PCI Geomatics for over 2 years now, and prior to PCI, I worked at the Canada Centre for Remote Sensing while completing my MSc in Geomatics. With us today, as a guest speaker, we have Minyo Hung, who is a founding member and a director of sales and marketing for Europe and Southeast Asia at SI Imaging, the world exclusive distributor of ComSat imagery. So previous to this role, Minyo has 13 years of experience in ground system development. And today, Minyo will be providing an overview of SI Imaging Services products, mainly ComSat-3 and 5. So to help conceptualize what PCI offers in terms of products, we have this diagram that depicts the various technologies that we offer as a platform. And the PCI Geomatica platform provides a framework that allows us and our customers to determine the appropriate tools that we offer to help them get the most from their imagery and solve problems of varying difficulties. So on the left, we have Geomatica, which is our desktop product that provides a plethora of tools and algorithms for image analysis and photogrammetric processing. Then on the right, we have our GXL system, a high-volume image production product. And both GXL and Geomatica are very similar, but GXL was specifically designed for automated image processing of large volumes of imagery, so truly designed to process terabytes of data each day by making use of parallelization, multi-processing, and distributed processing. Then finally in the middle, we have our Geomatica Developers Edition, which was developed for the Python scripting language. And this option really provides users with the ability to develop their own custom workflows for whatever their operational requirements may be. And with the Developers Edition, there's also a great amount of flexibility, allowing users to combine various technologies from third-party sources to develop powerful workflows for image processing. So before we get started today, I would just like to take a minute for our first poll. So I'm going to bring that up right now. There we go. So please take a moment to respond to the poll, and then we'll get started with the presentations. Okay, I'll be closing the poll in 15 seconds. Okay. So moving on, this brings us to the first presentation today. And this presentation, like I said, will be given by our guest speaker, Minyo Hong, from SI Imaging Services. So I will pass the screen to Minyo.
Hello everyone, this is Minyo Hong from SI Imaging Services. So I'm very happy to have a chance to introduce the ComSat imagery and their advantages to worldwide users. My presentation today will be focused on the Kompsat-3 and Kompsat-5 image and their advantages. And other satellites, such as the Kompsat-3A and Dubai-2 will be followed. The ComSat is a Korean national program for space development. It is developed by KARI, which is Korean government agency, and SI Imaging Services is in charge of the worldwide distribution. And now we have 4 satellites, 3 optical satellites and 1 SAR satellite. The ComSat-2, 1 meter, and ComSat-3, 70 centimeter, Kompsat-3A, 55 centimeter. All 3 of them are the optical satellite. And we have a Kompsat-5 with 1 meter X-band SAR satellite. This table shows a brief specification of Kompsat-3. It was launched in 2012, and it can provide 70 centimeter resolution images. And now we are preparing a 50 centimeter product. And it provides one panchromatic band and 4 multispectral band. One of its strengths is high data quantization. It provides the 14 bits per pixel data. And the other unique thing of the Kompsat-3 is its imaging time. It acquires image in the afternoon, 1:30. So this image is Kompsat-3 image over Dubai, and this is image over London. Kompsat-3 standard product level is 1R and 1G. Level 1R is for a radiometrically corrected product, and level 1G is for a geometrically corrected product. SRTM-DM is applied when level 1G processing. And all products will be provided in geotic format. And we provide the image in bundle or pen sharpened type. So for bundle product, we provide 1 panchromatic band and 4 multispectral band. And for the pen sharpened product, we deliver 4 multispectral band in 0.7 meter resolution. So this table shows the specification of ComSat-5. It is an X-band SAR and launched SAR satellite, and it was launched in 2013. So it have three major imaging modes: spotlight, and strip, and SAR mode. So this is an image over Beijing airport in UH mode. And this is an image of Armenia Stadium acquired in EH mode. So ComSat-5 have three major imaging modes: spotlight, strip, and SAR. So in spotlight mode, it can provide a 1 meter resolution and 5 kilometer swath image. And in standard mode, it can provide a 3 meter or 2.5 meter resolution image with a 30 kilometer swath. In wide swath mode, it can provide a 20 meter resolution image with a 100 kilometer swath. The product level of ComSat-3 is level 1A, level 1C, and level 1D. Level 1A is for a singular complex data, for amplitude and phase data, and level 1C and level 1D is for geocoded data. The DM, SRT and DM is applied when generation of level 1D product. The product will be provided in HDF5 or GeoTIFF format. So when a product is provided in GeoTIFF format, sometimes file will be separated for each data, like the amplitude and phase, or for each strip. So now we are preparing RPCs and GIM layers for the ancillary data. Also, interferometry is also available, and it can acquire same instance angle image every 28 days. So this image shows the ComSat-5 DM result acquired in ST mode image. The right one shows SRT and DM, so you can compare how ComSat-5 data is more detailed. We believe there are many benefits of ComSat constellation, and there are three major benefits. The one is we can provide the actual capacity to the users, and we provide both spatial, optical, and SAR data with a very unique time combination. And by using ComSat-3 and ComSat-3A, it is you can derive the very good result for spectral analysis. So we have now ComSat-2, 3, 5, and 3A, and also we have device 2, and Deimos 2 is also available. So by using these 6 satellites, we can acquire more than 3 million square kilometers per day. And ComSat-2 can have a very high duty cycle, so it can acquire more than around 8,000 kilometer length strip in one imaging acquisition. And the ComSat-3, it can provide many imaging chances to the customers. So this figure shows the example. So it was this image shows that ComSat-3 can acquire around 40 image strips within a month. The other unique thing is unique time combination and for optical and SAR satellite images. So the ComSat-3 and ComSat-3A is the only very high resolution sensor with a multispectral band in the afternoon. And most of the optical, very high resolution optical satellites image, take an image in the morning, but we don't know when there will be cloud or what event will be happened in what time. So frequent chance of the imaging is very important to get cloudless image or to have a very urgent monitoring. So by using this combination of ComSat constellation, that the visibility of the specific target will be increased and change detection within a day is also possible. So this is the example. We acquired image over a desert in US for a Hyundai car commercial advertisement. So by using Kompsat-2, Kompsat-3, Kompsat-5, and Deimos 2. So as a summary, we acquired these 4 images, and 3 of the images, Kompsat-2, Kompsat, and Kompsat-5, was acquired in same day and different timeline. And after 2 days, we also acquired Kompsat-2 images. And the other operators tried to acquire this image, but there was a cloud, or this texture was removed by the sand, so they couldn't get a valid images. As I mentioned that in my presentation, Kompsat-3 and Kompsat-3A provides a very high data quantization. It's the highest bits per pixel among the commercial imagery. This high quantization provides or results the better performance for the spectral analysis. So this figure shows the result of the sequence method by using satellite images. So the first one is a result of the Worldview 2, the 4 meters multispectral data. And the second one is a Kompsat-3 2.8 meter multispectral data result. So you can see that how Kompsat-3 can deliver the detailed steps of the change of the depths. And this is another result of the ComSat high data quantization. So left one is a Kompsat-3 and the right one is a LiDAR data result. So you can see that they are almost same. The only difference between LiDAR and the Kompsat-3 is 35 centimeter. We believe that this very good result of Kompsat-3 is due to the high correlation between 2 images in a stereo. Also, that meaningful data can be extracted from the shadowed area, and it can result the very beautiful mosaic result with the better color balancing. So now ComSat is used by several government agencies such as Europe and Canada and China, and it is also used for a large area mapping in India and China. And ComSat is also used for a regular monitoring for a construction site or the airport, and also in oil and gas industries. We have 2 more satellites. Kompsat-3A was launched in 2015, and it can provide 55 centimeter resolution images. And now we are preparing 40 centimeter products. So the spectral band or data quantization is exactly same with the Kompsat-3. So it also provides 14 bits per pixel, and it also acquires image in the afternoon, 1:30. And it will be officially commercialized in June or early July. So this is an example image of the Kompsat-3A. And Dubai-SAT-2 is launched in 2013. It is also 1 meter resolution satellite. It provides the 12 kilometer swaths and 1 panchromatic and 4 multispectral band. So this is a 1 meter pan-sharpened image over Dubai. And this is image acquired in consecutive days. So one of the unique characteristic of device 2 is the revisit. Device 2 can acquire image over same area, same target for 5 days in a row. So it is very good for applications that requires daily monitoring. Thank you. Thank you very much. And if you have any question, you can send the email by this email address. Thank you very much.
Well, thank you very much, Mignot, for that presentation. It was very interesting. Now, before continuing, I'd like to take a moment for our second poll. So I'm going to bring that up on the screen. So please take a moment, respond to this poll, and then I'll continue with my portion on monitoring applications. One quick note about the polls. If you selected the option Other, could you please specify what that other option is in the questions panel? Thank you. Okay, 10 more seconds. Okay, so we're going to continue now. So with my portion of the presentation, I'm going to focus on monitoring applications using ComSat-3 and 5 imagery with Geomatica. So Earth observation, well, it's well known to be a valuable approach to monitoring change over time. And that's because Earth observation provides the capabilities to acquire up-to-date information of the Earth's surface, but it also provides the ability to create historical databases or a historical record of that change that occurs over time. And that information is of great value across various sectors, where you'll find a number of different monitoring applications to help policymakers make informed decisions. For example, in the government sector, there's a strong interest in monitoring urban development for infrastructure planning, or for other tasks like detecting non-authorized development. You'll also find many other applications such as geointelligence for security purposes. Then in the energy sector, we have the petroleum industry, which will monitor pipelines to help ensure structural integrity, or simply monitor operational sites and their surrounding areas to help with risk mitigation. And last, we have the agricultural sector that performs a variety of different monitoring tasks, such as monitoring crop health for optimizing yields, monitoring the effects on crops of nearby urban growth, or simply using that information that's acquired to calibrate predictive models. Now, there are many other sectors that we could talk about and that make use of Earth observation for monitoring change, but what's important here, and that's common between all these different sectors, is the main purpose of the application of monitoring, and that's acquiring the necessary information for actionable intelligence. Now, acquiring the necessary information for actionable intelligence is no small task, and to do so you do need the right tools. So in the following portion of the presentation, I'm going to demonstrate how you can leverage both ComSat-3 and 5 products with Geomatica to extract meaningful information that decision makers and upper management can use. So I've divided the end-to-end monitoring workflow into two main portions. The first portion is image processing. And what I mean by image processing is taking your raw imagery and then applying a series of operations to generate a high-quality product that can be utilized for analysis. And then in the second portion, which is image analysis, I'm going to focus on applying another series of operations to generate and extract meaningful information, which is required for actionable intelligence. So for the first portion, image processing, here we have our standard image processing workflow. So in the first portion right here, we have the initial necessary steps to produce an orthorectified product that's highly accurate. And this orthorectified product is necessary for analysis later on. So this includes steps like GCP collection, tie point collection, and then bundle adjustment to compute new orientation and positional parameters for your imagery, and then finally orthorectification. But today what I would like to emphasize and talk more about is the second portion of this workflow. And that includes atmospheric correction and haze removal, pan sharpening and mosaicing. And I want to emphasize those tasks to demonstrate how to prepare and get the most out of your imagery for analysis. So after orthorectification, the first thing we do is atmospheric correction and haze removal. And in Geomatica, we provide the ability to perform advanced atmospheric correction and haze removal. And one of the advantages here is how simple it is to process Kompsat-3 imagery in our user-friendly wizard, especially since all the necessary parameters are automatically extracted for you from the metadata. So this makes the task of atmospherically correcting your imagery much easier. Now, some of the key atmospheric correction capabilities that we have for monitoring applications, well, the first one we have digital number conversion. And that's the ability to convert your digital numbers from either radiance to top of the atmosphere reflectance or to ground reflectance. And this is important because depending on your application, you may require a certain unit of measurement for the digital numbers. Then we have haze removal. And haze removal provides the ability to either reduce or completely remove haze from your imagery. And by doing this, it helps users get the most spatial coverage out of their imagery. And then we have cloud masking. And the ability to create masks over regions containing cloud is extremely valuable because these cloud masks can be used to exclude anywhere in the image where there's cloud cover from image analysis or color balancing tasks. So all these capabilities together really provide ComSat-3 users with the ability to do more with their imagery. The next task is pan sharpening. And performing this image fusion is of great value when it comes to monitoring applications. And in Geomatica, we have a well-recognized pan sharpening algorithm that produces high-quality fused imagery. And this helps users to more effectively analyze their imagery. So I'm going to jump out of PowerPoint right now, and I'm going to bring up some examples of some pan sharpened imagery from ComSat-3. So right here, I have two areas I'd like to show you. The first one is Houston, Texas, pardon me. And there's two areas I'd like to highlight in this pan sharpened image right here. So if we zoom down to where we have these two stadiums, right here we have the multispectral image. And from the pan sharpened image, this is what we gain in terms of information. So going back and forth, you can see that there's a lot of information that's fused into the imagery, the multispectral imagery from the panchromatic scene. So for example, right here you can see that we could read the writing on top of the stadium. Or in the parking lot, we're able to more easily see the outline of vehicles and the color of those vehicles. And on top of this stadium right here, you can see the pattern quite well. So there's a lot of information that's gained from doing this image fusion. Now another area that's quite interesting is the downtown core of Houston, Texas. So I'm going to zoom in right here. So here we have the multispectral image, and this is the pan sharpened image. So going back and forth, you can see that there's a lot of information that's gained from pan sharpening your imagery. If you look at the buildings, there's quite a bit of detail that you would simply not get in the multispectral image. Now for the second scene that I have, it's covering an area of New York, Brooklyn. So one area I'd like to highlight is Governor's Island right here. So right here you have the multispectral image. And as I flicker to the pan sharpen image, you can see the amount of detail you gain. So if you look at the detail in the forest and the canopy right here, and also if you look at the fort, I flicker it on and off, you can see all the information that you gain. As well, if you look at the terrain right here, you can see the outline of these stockpiles. So looking at this pan-sharpened image of an urban area, you can see that having pan-sharpened imagery is very valuable when it comes to monitoring applications, especially in urban environments. Now the final portion I want to discuss in image processing is Geomatica's Mosaic capabilities. And this is an area in Geomatica where we've heavily invested in developing our technology to be in a position to produce truly awe-inspiring results. And what's really valuable about our advanced mosaicing capabilities is that we've been able to reduce or completely eliminate the dependency on non-geospatial image correction software. And the importance of that is, well, one, you don't have to worry about having to convert your imagery between different file formats and to import and export it between software packages. Two, you don't have to worry about preserving scale among other properties when you're working in a non-geospatial environment. And three, well, there's a great amount of time that's saved by being able to perform many of these operations quickly and efficiently in Geomatica alone. So I'm going to highlight a few of these mosaicing editing and post-mosaic editing capabilities now, with a focus on some of our newer 2016 features. And one thing you'll notice is that everything I'm going to demonstrate is very user-friendly. So the first feature I want to demonstrate is our new interactive automatic color balancing functionality for dodging points. And this feature, in my opinion, is truly amazing. This new feature allows you to quickly edit the color balancing along seam lines by automatically determining the optimal brightness and contrast levels for you. So let's say previously a manual color balancing task maybe took 30 minutes to complete. With this new functionality, that 30-minute task can now be a 5 to 10-minute task. So it's an extremely convenient tool for doing color balancing. And with this new feature, there are three approaches to interactive automatic color balancing. We have auto match to both sides, which performs color balancing by matching the statistics of both images and performs, matches them to get a seamless transition. Then we have auto match to single side, which performs color balancing by using the statistics of only one of the images. And then we have auto match to two statistics. And this option allows users to select color balance statistics from one region of the imagery and apply it wherever they like. So to give you an example of this new feature, on the left we have an example of auto match to both sides. So by simply dropping a dodging point on my image, it gathers the statistics of both images and automatically color balance them together. And this, as you see, is very simple. You simply add one point and it does it for you automatically. And the same thing occurs on the right. So when we use auto match to single side, I simply drop a dodging point. It's going to take the statistics from one of the images and apply it to the second image, and then you'll get a seamless transition. So in both cases, all that was required was to place a dodging point and the color balancing was performed for you automatically. So I'm going to jump out of the PowerPoint again, and I'm going to give you an example of that to really show you how easy it is to color balance your imagery. So right here we have a ComSat-3 mosaic. And I'm going to highlight this one area right here where you can see the seam line between two images. And the reason for this, well, it has to do to seasonality. So when the images were acquired, well, they were obviously acquired in different seasons. If you look at the vegetation, you have quite a noticeable change in color. So what I'm going to do, I'm going to select my cursor and I'm going to choose one of the images. Then I'm going to select my dodging point. And before doing any modifications, I'm going to add dodging points to the extremities of where you don't see change anymore. And the reason why I'm adding these two dodging points right here is because anything that I'm going to do within these two dodging points are going to be limited and contained to that area. So now that I've delineated that sort of area, I'm going to go back to my dodging point option and I'm going to select Auto Match to both sides. So now to automatically color balance these two images, all I need to do is drop a dodging point. And as you can see, it's done for you automatically and it's quite effortless. And now those two images are perfectly color balanced. Oops. Now the last feature I want to present before moving on to the image analysis portion is our Smart Geofill tool. And this tool allows us to perform a variety of post-Mosaic editing tasks. It can also be used for many other image and DEM editing tasks as well. And the one task that I want to demonstrate today with this tool in the context of monitoring applications is exposure correction. And exposure correction will help us improve the ability to interpret imagery in regions where you'll have very dark or very bright pixels. So we're going to have a look at our Kompsat-3 Mosaic. And right here we have an airport. And as you can see with the airport, the pixels are very bright. And as a result, there's a lot of detail and a lot of features that we cannot distinguish naturally with our eyes. So what I'm going to do, I'm going to perform an exposure correction on that airport. So the first thing I need to do is add a new vector layer. So I'm simply going to add my vector layer. And now I'm going to delineate a boundary around the airport because the exposure correction is going to be contained within that boundary, so it's very localized. So I'm just putting the boundary around my airport, and there we go. So now that I have my boundary, I'm going to open up the Smart Geofill tool. So now using this tool, the first thing I need to do is simply click on Copy. And then I'm going to bring up the exposure correction functionality, and I'm going to activate it. So as soon as I activate it, you'll see that there's already an exposure correction that's been applied. Now what I need to do is modify the parameters to get the exposure correction that I need. So I'm going to modify the interior adjustment and the surrounding adjustment. And you can see that all these corrections are done on the fly. So it's easy to get the results that you're looking for. So there we go. So I'm satisfied with this. So you see by doing this exposure correction here, there's a lot of information that we gain. So if you look at what we have after the exposure correction and what we had before. So by applying this, by performing exposure correction, we really get more out of our imagery. So now we're going to move on to the second portion, which is image analysis. So in the first portion, I demonstrated how Geomatica can be used to process and produce high-quality ComSat-3 products. Now I'm going to demonstrate how we can use Geomatica to analyze ComSat-5 imagery. And within Geomatica Focus, there are hundreds of functions and tools available to perform anything from simple analysis to more complex analysis that require the development of custom workflows. And in the circumstance where there's a need for custom functionality, such as the integration of in-house algorithms or the integration of third-party packages, that can easily be achieved by using our Python API. which grants the user the ability to analyze their imagery in Geomatica with custom Python scripts. And as I mentioned before, the Python API can be used to achieve various levels of automation depending on operational needs. So the first application I want to demonstrate is monitoring land use change. And the purpose of this application is to effectively monitor change of land use at a regional scale. So one of the many difficulties with monitoring applications is being able to extract valuable information from a large collection of imagery that covers a large spatial and temporal extent. So with this application, I'm simply going to perform a series of operations leading up to an unsupervised classification. And the benefit of this workflow is being able to easily identify areas where change has occurred in regards to the land use. And this workflow that I'm about to demonstrate could be easily automated for whatever your operational requirements may be. And one last note, within Geomatica, there are numerous classification algorithms available along with tools that assist users to achieve the classification results that they require. So I'm going to bring up the first demo right now. So here we have two ComSat-5 mosaics. One of the mosaics combines imagery that was acquired in April 2014, and it has a polarization of HH. Then the second mosaic was acquired in May of 2014, and it has a polarization of HV. Now the first thing that I'm going to want to do right here is clip out an overlapping area of both. So here we have an area where we have 100% overlap between both imagery. And the reason why I did this is because I'm going to simulate a dual pole image from my two single pole images. And the reason why I want to do that is that I want to increase the quality of my unsupervised classification. So for visualization purposes, this is easy to do in Focus. I'm simply going to go to add a new image. I'm going to select RGB. I'm going to select my first image, and I'm going to assign its band to the red band. Then I'm going to go to my second image, and I'm going to assign it to both the green and the blue band, and click Finish. And here we have a dual pole image that I'm going to use for our image classification. So like I said, the purpose of doing this is to produce a more classification with a little more value than a single pole classification. So using this dual pole image that I created or simulated, I simply applied the ISO data algorithm, which is an unsupervised classification algorithm, and I applied a few rules to produce the following classification. Now, for this example, I don't have another pair of classified imagery to do change detection or feature extraction. I will show that in the next demonstration. But what I want to convey here is how easy it is to perform, well, first of all, to simulate a dual pole image using ComSat-5 imagery, and how easy it is to produce an unsupervised classification. And by doing this, you could easily perform change detection between different pairs of imagery at different temporal time steps. And this entire workflow could easily be automated since there's very little operator's intervention in this. So the second application I want to demonstrate is similar to the first one in many regards, but instead of using a classification to detect change, I'm going to examine the change in the backscattering response by comparing the sum of intensities of two images. And a significant change in the backscattering response is going to indicate a change in land cover. Now this is one of the many approaches available to detecting change with SAR imagery in Geomatica. There's also the ability to examine the phase differences, the Wishart distribution, and many more. And just like the first approach, this change detection workflow can easily be automated for operational requirements. So with this example right here, I have two orthos covering a region in southern France. In both my orthos, I've already applied a block averaging to them. So we have one ortho that was acquired in July of 2015, and it has polarization of HH. And the second ortho was acquired in June of 2015 with a polarization of HH as well. So to perform a change detection using those two images, what I need to do, I need to first generate the information to produce the change detection and then execute the change detection. And this can easily be done in one step using the CCD intents algorithm. So I'm going to open up the algorithm librarian. I'm going to bring up the CCD intents tool. And all I need to do is specify the working image, which is simply one of my images, a reference image, an output, and the most important parameter I need to specify is the window size. And for this application, I chose a window size of 15 pixels. Now I could have chosen a larger pixel size for the window, but I had already previously filtered my imagery beforehand. And it's very important to note that the parameter value assigned to the window size will dramatically change and impact the results that are produced from this tool. So once you run this tool right here, you'll get 4 layers. The first 2 layers are the intensity layers calculated from your ComSat-5 or SAR imagery. Then the next 2 layers are your results. Now the first change detection layer that we have represents the absolute difference in intensities. Then the second change detection layer we have is the difference in intensities with ranked percentiles. So you have the choice to use either or. Now for my feature extraction, I'm going to use the absolute differences. So now I want to extract, or I want to determine what is considered a significant change or a change of interest from my change detection. So to do that, I'm going to open up the XPolRAS tool. So I'm going to go back to the algorithm librarian, search up XPolRAS, and open it up. And what this tool is going to do, it's going to delineate polygons wherever there's a certain condition that is met. So for this, I simply need to specify my input layer, which is my change detection layer of the absolute differences, an output. And in the parameters, I'm going to specify a threshold. And that threshold is going to be used to determine whether or not the change that occurred is significant or of interest. And another parameter, an optional parameter that I did specify for this application as well, is the minimum area. And by specifying a minimum area, you remove and you'll reduce a lot of the noise that you would get from this. So once you run the XPolRAS tool, pardon me, what you will get are these extracted polygons right here. And as I flicker on and off between the polygons, you'll see that they're nicely aligned with areas where we can see there's a high level of difference, a significant amount of difference between the intensities of both images or in backscattering response. So these polygons are very important because using these polygons now, you can generate a lot of valuable statistics. So for example, you could simply generate statistics based on the geometry of the polygons. Or you could use these polygons to extract statistics or compute statistics from your ComSat-5 or SAR images. Or you could also start to combine optical imagery as well and use these polygons to generate statistics from optical imagery. So once again, this entire workflow right here that I demonstrated is very straightforward. It requires very little operator intervention, and the entire workflow can be scripted with Python. So to summarize my portion of the presentation, I demonstrated how by leveraging ComSat-3 and 5 imagery with Geomatica, organizations from various sectors can easily implement monitoring programs. And with these monitoring programs, you can extract valuable information which can then be used for actionable intelligence, and that's the purpose of all of this. And these monitoring workflows that can be developed can both process and analyze imagery with various degrees of automation with Python. Okay, so that ends my portion of the presentation. Before moving on to our Q&A session, I'm just going to take time for our third poll. So I'm going to open that up right now. So please go ahead and respond to the poll, and we'll get ready for the Q&A session in a moment. Okay, 10 more seconds for the poll. Okay. Pardon me. So before we start our Q&A session, just a quick note that a full trial version of Geomatica 2016 can be downloaded from our website. In addition, we now have our developer zone online, and as well as our support forum. The developer zone provides a plethora of Python scripting examples and tutorials, and if you have any questions or uncertainties about the software, please post a question on our support website and we'll respond to you in a timely manner. So now we're going to start with the questions. So actually, Minyo, I have one question for you before we get started. So if someone was interested in ordering stereo Kompsat-3 imagery, what would be the procedure to do so?
Actually, we have the 80 resellers worldwide, so the customers, users can contact them, and they are listed in our website. Or you can contact, customers can contact directly to me with the email address at the end of my presentation.
Excellent, thank you. Now we have a member of our audience that's wondering, what's the revisit time for ComSat-3 and ComSat-5 imagery? I think you mentioned that once during your presentation, but could you reiterate that, please?
The revisit time of ComSat-3 is around 3.5 days for equator area with a plus minus 30-degree tilt angle. And ComSat-5's revisit time is similar to ComSat-3, a little bit different but similar. But with ComSat-2, 3, 5, we have more chance. We can have more chance for the imaging.
Okay, thank you. Now one question from a member of our audience. Is it possible to obtain DMs from ComSat-5 imagery? And which are the better resolutions obtained? Now I can answer that. I've already, in the past, I have produced and extracted DMs using ComSat-5 imagery. In regards to the better resolutions obtained, I think I was using a 1:3, or maybe I was producing 20 meters. It's been a while. But yes, it is possible to extract DMs or surface models from ComSat-5 imagery.
Yeah, I will add the answer. The example in my presentation was generated by ST mode with a 3-meter resolution image, and also DM can be generated with the HR mode images, like 1-meter resolution images.
Okay, thank you. Now we have another question. Do we intend on adding the SVM or the RF classification algorithms into Geomatica? Well, that's a good question. At our user group meeting that occurred few months ago, we did announce that we are planning to release the SVM algorithm into our software at a later date. Now, a lot of you are also asking where you can download the webinar and the presentation deck. All of that is available online on our website. So you simply go to More Resources and go to the webinar section, and all of our webinars are available online, are available to download or either view on our YouTube page. Now, Mignot, we have another question here. Can we get free SAR data for research purposes?
It depends on what its purpose. So if we think it is very useful for us, then we can share this pre-sample data to the users. But we have to know what the purpose and what method and what kind of result is expected from the research.
Okay, thank you.
So yeah, let me know the interest.
Okay. Well, you provided your email address. Maybe I could provide that email address later on to the user, and you could get in contact with Mignot yourself and arrange that. Now, another question that we have, can ComSat images be helpful in the field of meteorology? Do you have an answer for that?
Meteorology. I have to check about it. Yeah. At this moment, I cannot answer to the question. Sorry.
Not a problem. 1 second, audience. Just let me go through the questions panel. Okay. So one question was, what image fusion operation was used in this demonstration? So a lot of the imagery, well, the images, the pan-sharpened imagery in my portion of the presentation, I used the pan-sharp 2 PPF that's available in Geomatica. And that's a tool that was developed, I think, a few years ago. It's one of our more recent pan-sharpening tools, and it produces really high results, as you saw. So if you have Geomatica, that tool is available to you. Now, another question, do you have any educational packages for universities? Yes, we do. As far as I'm concerned, we do have an educational program. You simply need to get in contact with our sales department, or I can get in contact with you afterwards and we could work out the arrangements. But yes, we do provide an educational package for Geomatica. Okay, so we're getting a little short on time. For the remaining questions, I will answer them afterwards by email. So a quick note before leaving you all. We will be on the road in the upcoming months. So we have a few events lined up. Here's a list of a few of them. Next, we have the Geospatial World Forum in Rotterdam. Well, I will be there with a colleague of mine. And if you happen to be in the area, please stop by the booth and I'd be glad to answer any questions that you may have about the software. And we also have other events in San Diego for the Esri UC. We have the ISPRS 2016 in Prague, InterGeo in Hamburg, and there are many other events that we will be attending this year that can be found on our website. So if you're able to attend any of these events, please stop by our booth. We'd be more than happy to say hi and have a chat with you. So this brings us to the end. I would like to say a big thank you to our special guest, Mignot from SI Imaging Services, and I'd like to thank the audience for taking the time today to attend and participate in our webinar. So thank you once again and take care.